All right. Then what is the valency of fluorine?
1.
1. Crossuna, aluminium gets 1 and fluorine gets 3. Then, okay, up to that point, is everything clear? Did you all get these answers? How is it? Others? All right, then let's move on. Now we are coming to radicals, which are polyatomic ions, if you remember, like those ions with like number of atoms. So we have calcium hydroxide, right? So calcium is Ca. Hydroxide, Mugad. What is hydroxide?
Hydrogen. 1.
Not hydrogen.
OH.
Yeah, it's OH. 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 Nikang OH liyan epa, because if you remember in the polyatomic ions table, they have a charge. Metan tin OH minus kila. So even when you're writing it here, write it as OH minus. So what is the valency of calcium?
2.
2. What is the valency of hydroxide, OH minus?
1.
1. Crossuna, calcium gets 1, OH gets 2. So OH can then 2 yanaman, it's common. So I put a bracket and put OH 2. Ammonium phosphate. Ammonium is NH4 plus, right? What is phosphate? What is phosphate? Quickly tell Namai. PO.
PO.
Yes, Kushit.
-3 4.
මුලින්ම 4 කියන්නේ PO4 ඊට පස්සේ තමයි charge එක 3 minus. Okay, so you first tell that because 4 means O හතරක් තියෙනවා කියන එකනේ. So even like let's say ammonium NH4 plus. Phosphate PO4 3 minus. At the end only we say the charge. Even the writing order should be like that. මුලින්ම PO4 ලියලා තමයි charge එක ලියන්නේ. Then what is the valency of ammonium? 1. What is the valency of phosphate? 3. Crossuna, ammonium gets 3. We'll have to put brackets. Ammonium. Antimekedi api charge. Metan thina charge we don't bring it to the last answer, right? So ammonium gets 3. Phosphate gets 1. So we don't really have to put 1. But this charge and this charge we don't put in the final answer. Are these two clear to you, Lamai? Give me a thumbs up if it's clear. All right, then aluminium dichromate. Aluminium is Al. What is dichromate, Lamai? What is dichromate? Quickly, what is dichromate?
Cr2O7 -2.
Yes, Cr2O7 2 minus. Yes, that's correct. Then what is the valency of aluminium? 3. What is the valency of dichromate?
2.
Yes, in the chat box also I'm getting answers. Good Lamaya. Then Samhara unmute karna. Samhara chat box එකේ දානවා. I see your answers, huh? Even though I'm not like reading out. I am reading out because unmute කරන අයගේ වයි chat box එකේ දාන ඔක්කොම මම read කරනවා. So keep it like keep it up. Aluminium 2, dichromate 2. Telling the answer or putting the answer in the chat box means that you have actually done it, right? If you don't respond at all, I'm going to assume that you have not done the homework. So aluminium gets 2, dichromate gets 3. Sodium. Sodium, we know it's Na. What is chromate, Lamai? Yes? CrO.
O 4 minus 2.
Yes. CrO4, 2 minus. In the chat box also, I got the answer. Good. So what is the valency of sodium? 1.
1,
What is the valency of chromate?
2.
2. Good. Sodium gets 2, chromate gets 1. So sodium 2, chromate 1. Okay, is that too clear before we move on to the rest? All good, right? If you have questions, please do ask. If you have questions, ask them, clarify, and move forward. I know sometimes you think, no, so I will figure it out on my own. Why bother? I mean, you can just ask, right? Unmute you can just put in the chat box, right? Unmute kala huwat kamak na. I mean, I would prefer if you unmute. That means that's also good, but I know some of you are shy, so you can just put in the chat box, right? Ammonium sulfate. And ammonium, we know already it's NH4 plus. Sulfate, what is sulfate? Yes, SO4, 2 minus. Good. Ammonium give valency 1, sulfate give valency 2, cross una, ammonium gets 2. We put a bracket. Ammonium gets 2, sulfate gets 1, so we don't really need a bracket. Then lithium phosphate. Lithium is Li. Phosphate is what? Phosphate is PO4, 3 minus. Lithium give valency 1, phosphate give valency 3. So lithium gets 3, phosphate gets 1. So like this. Is that too clear also? All good? Magnesium carbonate. Magnesium is Mg. Carbonate is CO3, 2 minus. What is the valency of magnesium? 1, not 1.
2.
2. What is the valency of carbonate?
2.
2. So both can be divided by 2. That would be 1, 1. So magnesium gets 1 and carbonate gets 1. That would be MgCO3. Then potassium. Pushit, is that clear? Okay. So potassium
Yes.
is K. Okay. Potassium is K. What is permanganate? MnO4 minus. Potassium give valency 1, permanganate give valency 1, cross suna, we get KMnO4. Then finally we have calcium sulfate. Calcium is Ca, sulfate is SO4 2 minus. Calcium give valency 2, sulfate give valency 2. Both can be divided by 2. So we get 1, 1. Calcium gets 1, sulfate gets 1. Then we get calcium sulfate. Last three also clear, Lamek? Hari, I will give you some time to do recorrections, not too long. Not too long. Habai ugala recorrection karaddi. I want you all to be careful about something. You know what? Ekak tamai, of course, like crossing numbers and all that. Of course, you have to be careful about that. Because the numbers wardina back, cross wardina back. Another thing that I want you to be very careful is capital simple. Sodium gatot him N is capital, A is simple. Phosphate gatot P is capital, O is also capital, right? Then if you take let's say sulfate or let's say manganate, permanganate gatot M is capital, N is simple, O is capital. Capital simple Baradot, your final answer is wrong. Okay, so please be mindful about that. I will give you like 3-4 minutes to do recorrections and we will start the new lesson. Okay, all right. I'll set a small timer. 4 minutes would be enough. It would be more than enough, but my 4 minutes then none. All right, do the recorrections fast. So while you write this, I sent some videos just for curiosity sake. Mama hitane ugalan group ekata එක මම ඔක්කොම groups වලට දැම්ම එක. එකක් I think I put කොහමද ඔටර්ගේ video එක දැම්ම. These are just videos that I find on YouTube or like TikTok or Instagram or Facebook. Like මම එහෙම scroll කරද්දී ඒ වගේ educational දේවල් දැක්කම educational and also they're quite interesting. So I once said that when I see stuff like that, I will share with you. I said that I used to share, but then students didn't really respond, so I stopped. But did you watch those videos? Did you see that otter video?
Yes.
Yes, miss, it was very cute.
Yeah, it was very cute. And also like, harima underrated sattu jatiyak koi Ceylon otter කියන්නේ Ceylon otter, they have the scientific name is lutra. They are very underrated because people don't really talk about them much. ඒගොල්ලෝ ටිකක් විතර rare. They are quite underrated because I mean even you may or may not have seen, but certainly not the type of animal that you talk about often, right? වැඩි කතා කරන්නේ නැහැනේ.
Miss, I have seen in the Hivala Zoo.
Yeah, දෙහිවල zoo එකේ ඉන්නවා. Yes, yes. Zoo එකේ ඉන්නවා, but like natural habitat එකේ quite rare. I'm not really a big fan of zoos because I don't believe that animals should be trapped. But දෙහිවල zoo එකේ ඉස්සර ගොඩක් හිටියා මං හිතන්නේ දැන් ගොඩක් අඩු වෙලා තියෙන්නේ. I heard that there was a time
Only three, yeah.
there were a lot.
Only three, Miss.
Only 3, no? Back in the days,
Yeah.
there were quite a lot. ඊට පස්සේ දේවල සුව එක මාර decline වුණා. ඒ සත්තු ගොඩක් විනාශ වෙලා
That bear is very thin.
Yeah, that's why they're not getting nutrients properly. I really don't like zoos at all. I don't like how animals are treated there. I see videos on internet, not just in Sri Lanka, in other countries as well. And it's absolutely depressing how animals are treated. So I don't even visit zoos and aquariums. My yannit naha. I'm not saying that you should not go, but I'm just like giving you my personal opinion. I don't like because they're not treated well. Because once I went to Pinnavala Zoo, I think 4 or 5 years back. Ek among most recent zoo visit 4 or 5 years back. And I saw like bears. They're supposed to be like all big and fluffy, but they were like very scrawny. They have lost weight and their fur has gone. It was very depressing. Anyhow, I think our animals again him trap kala tiyanne one sattunne. I mean, nobody should be trapped, right? So that's really bad. That's not very ethical, as I believe. But I like I'm okay with all these udawala vayala because they can freely roam. They have the freedom. And අපිටත් freedom එක තියෙනවා බලන්න ඒගොල්ලන්ටත් freedom තියෙනවා move වෙන්න ඒක අවුලක් නැහැ. I just don't like the concept of zoos. කොහොම හරි මම කියන්න පටන් ගත්තේ just because I shared it. රිදියගම මොනවද තියෙන්නේ සෙනදී? So Ceylon otter ගත්තාම free land area. There's no zoo, right? Ridhigama zoo I have not heard. Right. That's good. That's හොඳට සතුන්ට හොඳට ඉඩ ඕනේ. ඒගොල්ලන් හොඳට ඉඩ ඕනේ. දැන් හිතන්න අපි කියලා අපි එක තැනක ගොඩාක් කල් ට්‍රැප් කරලා අපිට හරියට කැම දෙන්නෙත් නැහැ. අපිට ඉන්න පුළුවන්ද? We are also animals, right? We are just a little more නෙවෙයි. We are quite a bit more evolutionarily advanced. And also like our brain and everything is more developed. That's true, but we are also animals. අපිව cage කරලා තිබ්බොත් අපි කැමති නෑනේ. ඒ වගේ තමයි. ඒක තමයි සෙනුදි මම එක දැකලා තියෙනවා මේ videos. එතකොට ඕගලන් වාහනයක යනවා ඒගොල්ලන් වටේ freely ඇවිදිනවානේ. Quite similar to safari concept. Anyhow, දැන් මම කියන්න පටන් ගත්තේ Ceylon otter එක. Ceylon otter ගත්තොත් එහෙම they are like they are living in aquatic environments. These are just interesting things. අපි හැමලෙම syllabus එකටම කොටු වෙන්නේ නැතුව we can talk about other interesting stuff as well, right? So when you take the Ceylon otter, අපි සිංහලෙන් කියන්නේ දියබල්ලා කියලා. right? දියබල්ලා කියලා කියන්නේ ඒගොල්ලන්ට පුළුවන් වතුර යට ඉන්න about 4 to 5 minutes, right? They can stay underwater like without breathing. They can't breathe underwater, right? Fish la wage they cannot breathe underwater, but they can stay underwater for like 4 to 5 minutes. And also, Lamai, you have seen the whiskers, right? Have you seen pictures or anything? You may have seen whiskers. Otter ki thina whiskers. Whiskers marm honda. They're very sensitive.
Yeah.
Have you seen others?
Yeah.
A video එකෙත් පොඩ්ඩක් විතර පේනවා. Yeah, and so these whiskers are very sensitive. ගොඩක් වෙලාවට these Ceylon otters, they feed on fish and they feed on crabs ලා වගේ පොඩි පොඩි සත්තු වතුර ඉන්නේ ඒගොල්ලන්ගෙන් තමයි feed වෙන්නේ. So their whiskers can sense when fish come near them, or when like a crab, or like they even feed on frogs, right? So if they come near, they can sense them through the whiskers. එතකොට ළමයි sometimes even very muddy water අතන ගොඩාක් muddy නම් වතුර you can't really see through water නේ. But even without seeing, they can still catch the fish because their whiskers can sense. ඒ කියන්නේ ඇහැට පේන්නේ නැති වුණත් ඒගොල්ලන්ගේ whiskers වලට දැනෙනවා. They would just quickly go.
Even the cats can, miss.
Yeah, cats also have like sensory endings in their whiskers. That's true. But cats lage specialty එක තමයි cats have excellent vision. So it's not that they cannot see, it's actually because they can see too well. අපි කියන්නේ like dogs have excellent nasal nasal neurons, nasal sensitivity, whereas cats have excellent vision, right? So yeah, Ceylon otters are quite interesting. And තව එකක් තමයි ඒගොල්ලන්ගේ interesting, you know, they use feces to mark their territory. ඔයගොල්ලන් දැකලා තියෙනවද ළමයි මේ බව්වෝ හැම when they want to mark their territory, they would urinate in that territory. Have you noticed that?
Yes, miss.
Yeah. What about others? No? Yeah. So ගොඩක් වෙලාවට dogs are කරන වැඩක් ඒක. ඒ වගේ otters දත් ඒගොල්ලන් territory එක mark කරනවා. ගොඩක් සත්තුන්ගේ ළමයි they have things called territory. ඒගොල්ලන් ඉන්න area එක. ඒ area එකේ තමයි ඒගොල්ලන් නිකන් full, you know, අපි කියන්නේ scene එකේ ඉන්නවා කියලා. So they are like thriving in that area. So if otters are gone, otters they use their feces, simply poop, right, to mark the territory. If the territory එක mark කරන්නේ ඒගොල්ලන් feces වලින්. That's quite interesting. ඒක මම ඇත්තටම හොයාගත්තේ when I saw that video. ඒ වීඩියෝ මම වීඩියෝ එක එවන්න කලින් චුට්ටක් එක fact check කරනවා මොකද ඕගොල්ලන්ට වැරදි වෙලා that's not right නේ. So when before sending I just quickly Google search and check facts. එතකොට තමයි මම ඒක දැනගත්තේ like about how they mark their territory. So they are quite interesting animals. They're quite cute too, right? ඔයගොල්ලන් Google කරලා බලනකො photos, they are very cute. Okay. Anyways, and also they're very playful. හරිම playful ඒගොල්ලන්. Zoo එකේ ඉන්න කට්ටිය නම් මම දන්නේ කොහොමද කියලා. මං ඉස්සර චූටි කාලේ යද්දී නම් they were quite playful, but even in the natural habitat they are playful. But the problem is ඔය Ceylon otters ටිකක් ඒගොල්ලන්ගේ population එක අඩු වෙවි යන්නේ. They are extinct වෙනවම කියන්න බෑ because there are quite a lot. However, the population is decreasing because of water pollution. ගොඩාක් දැන් pure and clean water අඩුයිනේ natural habitat එකත් අඩුයි. Because of things that we do, most of even the natural habitats like rivers, lakes, tanks, ponds, all of these are like polluted. And also අපේ fishermen ලා ගිහිල්ලා ළමයි ගොඩක් fishing කරනවානේ. Fishing කරනකොට දැන් I remember back in the days I visited a fishing village. ඉතින් ඒකේ fishermen ලා හරිම හොඳට fishing කරන්නේ. ඒගොල්ලන් දන්නා එක කාලවලට විතරයි fishing කරන්නේ. එක එක they have like amounts. මේකට වඩා fishing කරන්න හිතන්න එක දවසේ මාළුවෝ 50ක් අල්ලනවා කියලා. ඒගොල්ලන් ඊට වඩා fish ලා අල්ලන්නේ නැහැ. Right? Because ඕනට වඩා fishing කරොත් එහෙම එතන ඉන්න fish ලාට එක නැති වෙලා යනවානේ. So එහෙම but not all fishermen are like that. සමහර කට්ටිය they only care about earning money. ඒක ඒගොල්ලන්ට වැරද්දක් කියන්න බෑ, but still they only care about earning money. They don't care about the damage they're causing to the environment. So in most of the areas, fishermen have fished a lot. We call it overfishing. ඒතර overfishing වලින් ගොඩාක් fish lover අල්ලලා otters අට එහෙම කන්න කැම නැහැ. එහෙම ඒකත් හින්දා ගොඩාක් otter population එක අඩු වෙලා තියෙන්නේ දැන්. ඒකයි මේ වීඩියෝ එකේ ඒ වීඩියෝ එක ඔයගලන් දැක්කද දන්නේ මම මේක ඩවුන්ලෝඩ් කරේ TikTok එකෙන්. ඒ caption එකේ තිබ්බා it's quite a rare sight කියලා. Foreign planes වල තමයි ඒක දැකලා තියෙන්නේ. Okay? All right, just sharing because any questions? Just
No,
share.
miss.
Right, okay. So just sharing because these are things that we can be curious about. හැම වෙලේම අපි I mean of course we have to do the syllabus but syllabus එකේ මේවම විතරක්ම කර කර හිටියම එපා වෙනවනේ. But actually if you take science is much more interesting. There's so many interesting things to learn about, read about, find about, watch about, right? So because wherever you go you have science, right? වටේ බැලුවොත් එම science දේව කොච්චර පේනවද? Right? So it's all science. Science is there in your day-to-day life. ඒකින්ද I think ඒ වගේ interesting දේවලුත් චුට්ටක් දැනගෙන කියවලා බලලා ඉන්න කොහොඳයි. එතකොට we develop this interest for the subject. Yes. So when I see other interesting videos I wish මම තව එකක් කියවුවා නේද ඔයගලන්ට? Did I share that ice cream video? ඒක නම් AI වීඩියෝ එකක් but ඒ ඔක්කොම මම චෙක් කරා. ඒකේ මම සමහර ඒවා දැනන් හිටියා මමත් දැන ඉගෙන ගන්නවා දේවල් ඔයගන් ඔය දකින්නේවා මම ඉගෙන ගන්න දේවල් when I find them interesting only I decide okay I should share it with you. මම ඒකේ වන්න කලින් ඒකත් fact check කරා ඒ ඔක්කොම ඇත්ත. But I found some other interesting information like ancient China වල තමයි ඉස්සරම ice cream හදලා තියෙන්නේ. Like what they have done is like during the winter time ඒගොල්ලන් snow and ice mix කරලා fruit සුයි milk එක mix කරලා they have made this ice cream. ඒ කාලේ ඒගොල්ලන්ට ice cream කියලා නෙමෙයි they have used it as a dessert but apparently that was like the earliest beginning of ice cream. Okay, anyways, let's jump back to our lesson. Did I give any other homework? මම මේක දුන්නේ නැද්ද මොකද්ද මේ textbook exercises මොකද දුන්නේ නැද්ද? No?
No, teacher.
All right, okay. All right, it's okay. Today I will give it as homework. Newton laws of motion වලට ළමයි note එකක් නැහැ. මම හිතුවේ note එකක් තියෙනවා කියලා. That's why I might have told you in a previous week that I will share that note. But ඒකට note එකක් නැහැ. Friction වලට note එකක් තියෙනවා. ඒක මම අනිවාර්යෙන් එවන්නම්. Friction වලට තිබ්බද කොහෙද? I will just anyways I will check because there are so many notes. Sometimes I forget which notes I have and which notes I don't have. මොකද ගොඩක් physics වලට මේ there are no printed notes. Biology, chemistry වලට තමයි තියෙන්නේ. Okay, put the topic Newton laws of motion. Newton laws of motion. Okay, now don't write anything, just listen. Nah? Please give me a second. Please give me a second. Yes, I asked you to give me a second just to plug my laptop to the charger. All right. So now don't write anything. Just listen. What do we know about force? Because we have learned a little bit about force previously as well. So, what kind of things can force do? ලියන්න එපා. මොකද මේක නෙවෙයි note එක. we are just discussing. I'm explaining. This is just teaching, learning, not note writing. හරි. So let's say there is a tennis ball here, right? I want to throw this tennis ball to someone opposite of me. Like we are playing, catch, right? So if I want to throw the tennis ball to that person, do I have to apply a force? What do you think? Do I have to apply a force?
Yes.
Yes. I have to apply a force, of course, right? Then on the force වලට කරන්න පුළුවන් එකක්, right? We can start a motion. Motion එකක් කියන්නේ මොකක් හරි move වෙන එකනේ, right? Something moving is motion. So by throwing the tennis ball, to throw the tennis ball, I have to apply a force. That means a force is capable of starting a motion. Then let's say the person opposite to me is throwing the tennis ball towards me. Yeah, I'm at මට බෝල එවනවා. Then I'm going to catch it. Am I applying a force now? When I'm catching the tennis ball, am I applying a force? What do you think? Just yes or no. When I'm throwing a ball, I'm applying a force. When I'm catching the ball, am I applying a force? Actually, I am.
No.
Good that you answered, but I got different answers. Good. However, we are applying a force. Then hitanna tennis ball mage පැත්තට එනවනේ. If I don't catch it, it will just pass me and go. Right? So that will continue the motion. But by catching it, I'm stopping the motion. And I'm blocking it. So I am applying a force when stopping the motion too. Right? So when I'm starting a motion, I'm applying a force. When I'm stopping a motion, I'm applying a force. Okay? Then let's say, අපි හිතමු example එකක් විදියට ඔන්න cart එකක් තියෙනවා. Right? I can't draw a cart. Cart එකක් තියෙනවා. මෙතන bull කෙනෙක්ව ගැට ගහලා තියෙනවා. I can't draw a bull either. So just imagine that this is a cart. Okay? So එතකොට ඔන්න දැන් cart එක obviously ride කරන කෙනා ඉන්නවනේ. The cart driver is making sure that the cart is going forward. Right? මේ bull cart එක ඉස්සරහට pull කරගෙන යනවා. Right? So the bull is applying a force, right? Because it is like pulling the cart forward. මම මොකද කරන්නේ? මම මෙතනට ඇවිල්ලා මම තල්ලු කරනවා කාට් එක ඉස්සරහට. තව එක්කෙනෙක් let's say මායි මගේ යාළුවයි. But the two of us are like pushing the cart forward. Right? Now will the cart move faster? Yeah. Now, so here what now? Me and my friend, we have applied a force to the cart, right? Cart එක යන direction එකටම අපි දෙන්න force එකක් apply කරනවා. So එතකොට මොකද වෙන්නේ? Cart එකේ speed එක වැඩි වෙනවා. ඒ කියන්නේ a force can also increase the speed of a motion. Now what did we say? A force can start a motion. A force can stop a motion. A force can increase the speed of a motion. Right? Then මෙහෙම දෙයක් හිතමු. Now the cart is going now. මායි මගේ යාළුවයි cart එක පිටිපස්සට අදිනවා. Without giving it a force to the front, as the bull is pulling the cart forward, අපි දෙන පිටිපස්සේ නම් cart එක පිටිපස්සට අදිනවා. Will that decrease the speed of the cart? That will decrease the speed of the cart. So when me and my friend are pulling the cart backward, we are applying a force, right? But that force is decreasing the speed of a motion. A force can start a motion, a force can stop a motion, a force can increase the speed of a motion, a force can decrease the speed of a motion. All right. Then let's say you're playing badminton, right? Your opponent is throwing the shuttlecock towards you with that racket. So, ඔයා මොකද කරන්නේ? ඔයා shuttlecock එකට ගහනවා ඔයාගේ racket එකේ. එතකොට most of the time the direction of the shuttlecock will change, right? Your opponent is throwing the shuttlecock towards you. you're striking the shuttlecock using your racket. So it's a shuttlecock direction. So when you are striking the shuttlecock, you are also applying a force. But now what that force has done is it has changed the direction of a motion. Is that clear, Lamai? Is that clear? Others? Okay. So එතකොට මොනවාද force එකකට කරන්න පුළුවන්? So what are the things that a force can do? A force can a force can start a motion, a force can stop a motion, a force can increase the speed of a motion, decrease the speed of a motion, change the direction of a motion. All of these things can be done by force, right? එතකොට අපි හිතමු no, before that I think we will write a little something. මම textbook එකේ තියෙන විදිහටම නෙවෙයි ඔයගලන්ට කියා දෙන්නේ because a part of that we will be discussing in the next lesson. So let's not like overwhelm ourselves. We'll talk about all the important things, but don't worry about what I'm teaching you and what's on the textbook. Because whatever is on the textbook, I will be eventually teaching you. But ඒකේ ඒ විදිහට මම දැන් කියනවා කියන්න බෑ. But I will definitely make sure that you know everything that's on the textbook, right? Okay. Before we write, I want to ask you something. This is based on what you already know. Is force a scalar quantity or a vector quantity? Is force a scalar quantity or a vector quantity?
Vector.
Okay. I got one answer as vector. Vector. It is a vector quantity, yes. You guys are correct. Hamoma vector කියලා කිව්වා, very good, right? What is a vector quantity anyways?
A force which contains magnitude and direction.
Correct. So a vector quantity is any quantity that you can describe using both the magnitude can value vector and the direction. Right? So you have to use it can be described by both the magnitude and the direction. If it was a scalar quantity, only magnitude, we don't talk about direction, right? So in addition to force, what are other examples for vector quantities? What are the examples for vector quantities? Alamai?
Acceleration.
Acceleration, displacement, okay, what else?
Weight.
Weight, yes, what else?
Displacement.
Displacement, okay, what else?
Velocity.
Velocity, okay, good, yes. All right, then let's start writing. I will be, I already started writing the first sentence, so you can write with me so that we can save time. Okay, start. ළමයි මෙතන මම තව චූටි sentence එකක් add කරනවා. A force can change the shape of an object too. Chuttak, can you post writing? I will give you time to write, don't worry. Just post your writing for a second and look at this sentence. When I say a force can change the shape of an object, can you all tell me an example? Force එකකින් කොහොමද? How can we change the shape of an object?
Change the direction.
That is changing the direction. What about shape? If you take any object, they all have a shape, right?
Sides. Changing the sides.
How to change the sides? Crushing a paper. Yeah, crushing a paper, okay. Because if you take a paper, it's like a rectangular, very thin sheet of paper, but you apply a force and you crush it. Now it's like all wrinkled and it's a crushed piece of paper. Okay, that works. What else?
Stretching rubber.
Hmm?
Stretching rubber.
Rubber, right?
Yes.
Yes, stretching rubber. Yes, that is very true. That is the example I had in my mind too. A force can change the shape of an object කියලා කියපු හැටිම මගේ ඔළුවට මුලින්ම ආපු example එක තමයි rubber band එක, right? So yes, that's also a good one. Stretching rubber. So if you take a rubber band, you can pull it on both sides and you can stretch it. So you're changing the shape. What else? What will happen if I drop a glass? When I'm dropping a glass, when it hits the floor, it applies a force and that will shatter the glass, that will change the shape. Straightening a paper pin, okay. හොඳට තියෙන paper pin එකක shape එක කැත කරන්නත් පුළුවන්. නැත්නම් ඒ කැත වෙලා තියෙන එකක shape එක ලස්සන කරන්නත් පුළුවන්. එහෙම නැත්නම් ආගත්තොත් එම්ම තඩි metal block එකක් like iron වගේ, right? Like යකඩ. So අරගෙන if you hammer it, මිටියකින් ගැහුවම when you strike it with a hammer, it gets flattened. Again, we're changing the shape. So those are some examples for that. All right, so quickly write this, Samay. I'll give you 2-3 minutes. Quickly write. All right, done ළමයි? Okay. 1 minute, huh? I gave you enough time, but I will give you 1 minute. Okay, quickly write.
Did you say anything?
No, I gave you 1 extra minute because one of you asked. Have you all finished? Others too? Okay. හරි ලියන කට්ටිය I mean මේක ලියන්න නම් එච්චර වෙලාව යන විදියක් නෑ but ලියන අය ලියන් යන්න but I will start explaining the rest of it. Now force measure කරන unit එක මොකක්ද? It's newtons. Force is measured by the unit newtons, right? Newtons, the symbol of the unit is capital N. We will see how to apply it in the future, right? Why do we call it Newton? I mean Newton කියලා නමක් දාලා තියෙන unit එකට force වල. Yeah. It's named after may unit එක what was like who was it named after? Unit of force. Who was it named after? The person. You know this? Come on, lamai. Out of all the 16 of you, එකෙනෙක්වත් දන්නේ නැති වෙන විදියක් නැහැනේ. Who's the guy after which Isaac Newton? Yes, the Apple guy, Isaac Newton. Right. So you know the very dramatic story of Isaac Newton. It's not that dramatic. The cartoons වල එම තියන්නේ like එකපාරට Isaac Newton ගොළුවට apple ගෙඩියක් වැටිලා then he starts finding about force and gravity and all that. That is kind of true because එයා ගොළුවට වැටුණ apple ගෙඩියක්. As far as I know the story, the real story is not like that. එයා නිකන් ගහක් ඇටලා ඉන්නකොට එයා දැකලා තියෙනවා he has seen an apple falling down. And he was like, okay, එයාට එකපාරට කල්පනා කළා okay, ඇයි apple එක පල්ලෙහාට වැටුනේ උඩට යන්නේ නැතුව කියලා. I mean, that's a very normal scenario, but he started thinking about it more. එතකොට තමයි එයා gravity ගැන discover කරගත්තේ, right? Gravity එක තමයි එයා force ඔක්කොම ගැන discover කරේ. And like he's actually a very interesting person. Ogolang, like what you know about Isaac Newton is that he discovered force and he discovered gravity. But it's not just that. Yeah, godak mathematical. There is an entire section of mathematics called calculus. Calculus gan godak deval ya discover karagatta. It was a light gan how light behaves. Eva gan ya godak discover kara. The story says that ඒ කාලේ ලන්ඩන් වල තිබිලා තියෙනවා great plague කියලා like there was this like virus එකක් වගේ plague එකක් spread වෙලා ගිහලා තිබිලා ඒ කාලේ ඔක්කොම quarantine කරලා තිබිලා තියෙන්නේ. So ඒ කාලේ කාටවත් ගෙදරින් එළියට බහින්න නැති වෙන everybody was like stuck in their houses. So ඒ කාලේ හැම Isaac Newton මාර විදියට he has done a lot of studies about like calculus, light and also force. So එතකොට එයා ඒ කාලේ he has put forward some laws of motion. We are going to discuss those in this lesson. Newton's first law, Newton's second law, and Newton's third law කියලා අපි laws කීපයක් ඉගෙන ගන්නවා. Quite an සමහරවිට ඔයගොල්ලෝ අහලත් ඇති මේක Isaac Newton ගැන. He was like a very antisocial person. Like he was like very antisocial, and එයා නිකන් මාරම ඔය ගොඩක් scientistලා and හරිම world famous scientists and physicians ගත්තොත් the best example is Albert Einstein. They're like very obsessed with their work and they're like quite antisocial. So ඒ වගේ තමයිලු Isaac Newton. So yes, he's quite an interesting guy. You may have heard, some of you might have heard, some of you might not have. But yes. So anyways, that's what force was named after. Isaac Newton ge ඔක්කොම discoveries වලට එයාට මාර විදිහට honor කරා England වල. එයාට මේ he normally අපි Isaac Newton to refer කරාද, we don't just say Isaac Newton. We say Sir Isaac Newton. Because ඒ කාලේ Sir කියන්නේ title එකක්. ඒක Queen දෙන title එකක්, and he got awarded that title. ඒ කාලේ තිබෙන knights ලා හැම කියලා. Knight කියන්නේ title එකක් නේ, that is awarded by the king or the queen or whoever. So ඒ වගේ තමයි මේ Sir කියන title එකක් apparently. So එයාට Sir Isaac Newton කියලා තමයි කියන්නේ. එහෙනම් කියන්නේ මම ඒ දවස්වල කියුවා එක මේකක් මේ an article where like Isaac Newton has done a lot of එයා තමයිලු calculus කියන mathematical field එක පටන් ගත්තේ මුලින්ම. හැබැයි ඒත් එක්කම තව mathematician කෙනෙක් ඉඳලා තියෙනවා. I can't remember his name, Leibniz or somebody. එයාත් වෙනම calculus වාගේ. So these two people have independently discovered calculus. ඊට පස්සේ ඒ කාලේ එනම drama එකක් තිබිලා පොඩි රණ්ඩුවක්, academic රණ්ඩුවක්. මම තමයි මුලින්ම හොයාගත්තේ. ඊට පස්සේ ආර නිකන් නෑ මමයි මුලින් හොයාගත්තේ කියලා. It's quite an interesting story. If you're interested, you can Google search and read about it. මට එම ගොඩ කාලයකට කලින් කිව්වේ, so I can't remember the exact details, but yeah. මට දැන් නිව්ටන් ගැන කියද්දි එක මතක් වුණේ. ඔයගන්ට ඒක interested නම් you can read. නැත්තම් ළමයි no. I will tell that later. Okay, anyways. Newton laws. Now we are coming to talk about Newton laws of motion. Newton ගේ laws කීපයක් තියෙනවා. මං කියවන අර යා great plague එක කාලේ quarantine වෙලා ඉන්න කාලේ ගොඩක් study කරලා තියෙනවා motion ගැන, force ගැන, gravity ගැන ඒවා. ඒ කාලේ තමයි එයා පොත් එහෙමත් ලියලා තියෙනවා ගොඩක්. So he has put forward 3 laws of motion. Newton's first law, Newton's second law, and Newton's third law. Those 3 are what we are going to be discussing in this lesson. That is the main part of the lesson. So please put a topic. Newton's first law. Newton's first law. Abi first law එක ලියලිමු, then we can talk about it later. මේ පොතේ තියෙනකම තමයි We can write the law and then we'll talk about it. All right. So what does this mean? Make a lama, if possible, like put a star or something, make a highlight karaganna. And remember, Newton laws tika liyanna puluwan wenna one. If I ask you to write Newton's first law, you should be able to write this. Eka hinda poddak podi katapadang ekak karanna wenawa etana. But katapadang කරද්දී understand කළා katapadang කරනවා නම් අවුලක් නැහැ, right? So try to understand this. So let's say මෙහෙම body එකක් තියෙනවා. Body එකක් කියලා කියන්නේ some object. So first of all, I will talk about this term unbalanced force. Okay, unbalanced force. හිතන්න මම මේ පැත්තෙන් මේ object එක pull කරනවා with a 10 Newton force. And let's say Shweta මේ පැත්තෙන් මේක pull කරනවා with a 10 Newton force again. Is the object going to move?
No, it will remain stationary.
It will remain stationary. That's correct. It will not move. However, if Shweta gives, let's say, 12 Newton force, will the object move?
It would move to the opposite direction with the
Yeah,
2 Newton force.
yes. මෙතන විතර extra 2 Newton force එකක් තියෙනවා. එතකොට යා මේ පැත්තට move වෙනවා. Is that clear to everybody? That scenario? Yeah, to the right. එතකොට දැන් බලන්න if I apply 10 newtons and Shweta also apply 10 newtons, now it's balanced, right? එතකොට දෙක balance වෙලා, so the object is not moving. But if Shweta gives 12 newtons, this is going to move in this direction. මොකද දැන් මේක balance නැහැ. Because Shweta has given extra 2 newtons. Extra 2 newtons. That extra 2 newtons is the unbalanced force. Balance වෙලා ඉන්න කෙනෙකුගේ balance එක නැති වුණාම that extra force is called the unbalanced force. Right? So, if you take an object, හිතන්න මෙහෙම object එකක් තියෙනවා, now it's stationary, it's not moving. An object that is not moving, හිතන්න for an example, this glass is here. මම unbalanced force එකක් දෙනකන් එයා ওই විදිහටම ඉන්නවා. It will just stay like that, it will not move. But the moment I give it some unbalanced force, it will start to move. Right? දැන් මෙහෙම තියෙනවා. හැබැයි මම මෙහෙම push කරොත් එහෙම එතනම පොඩි unbalanced force එකක් එනවනේ. ඒකෙන් එයා move වෙන්න පටන් ගන්නවා. So unbalanced force එකක් දුන්නහම objects that are stationary will start to move. Okay, Maria. Let me know when you're leaving. So, okay. So anyways, objects that are stationary will remain stationary as long as I don't give an unbalanced force. But if I give an unbalanced force, what will happen? The stationary object will start to move. ඒකයි මෙතන කියන්නේ until an unbalanced force is given. Unbalanced force එකක් දෙනකන්. ඒ කියන්නේ තාම unbalanced force එකක් දීලා නැහැ. Unbalanced force එකක් දෙනකන් stationary ඉන්න කට්ටිය stationaryම ඉන්නවා. Unbalanced force එක දුන්නොත් මොකද වෙන්නේ? එතකොට ඒගොල්ලෝ move වෙන්න පටන් ගන්නවා. But until an unbalanced force is given, objects at rest will remain stationary. Then ළමයි summer objects තියෙනවා, they will move in uniform velocity. හිතන්න already move වෙන object එකකට. Let's say this is an object, this is already moving with a velocity of, let's say, 5 meters per second. Yeah, already move වෙනවා ළමයි. Already move වෙන එකට, let's say මම මේ පැත්තට දෙනවා 5 Newton force එකක් and let's say සඳරු මේ පැත්තට දෙනවා 5 Newton force එකක්. Now again balance වෙලානේ. However, the object was moving earlier, right? මුලදී object එක 5 ms minus 1 velocity එකකින් move වෙවි හිටියේ. Now I give a force to one direction with 5 newtons. Sandaru is giving to the opposite direction with 5 newtons. is it balanced or unbalanced? The object is moving. That's a different story. But just look at the forces and tell me, is it balanced or unbalanced? It's balanced. එතකොට මොකද වෙන්නේ? මේ object එක forever 5 meters per second වලින්. Yes, Nipuna. Nipuna, are you a newcomer today? You can either unmute or put in the chat box. Let me know. Let me know if you're a newcomer, if it's your first day today. All right. So I give 5 newtons, Sandra gives 5 newtons, 5 Newton balance whenever. Now the object was anyways moving now. It already had a velocity of. Yes, Nipuna. Any question? Any problem? What's going on? Okay, if you all have any problem, any question, you can let me know in the chat box. Huh? Okay. Back to what I was talking about. This object was already moving with a velocity of 5 ms minus 1. And mama 5 Newton force එකක් දුන්නට සඳරු අනෙක් පැත්තට 5 newtons දීපු එක balance. Since it's balanced, this object will forever move at 5 ms minus 1. A velocity, it's a uniform velocity, right? එකම velocity එකෙන් යනවා නම් we call it a uniform velocity. So the object will continue to move at uniform velocity. But make a practical, but you know, in real life, let's say මොකරි object එකකට force එකක් දෙනවා. And it will start moving. And then it will gradually become slower, and it will stop, right? Okay, it will stop. So, all right, okay, Sanjana. Okay. So, mom බැලුවා නිපුණ කියලා තියෙද්දි is it a newcomer කියලා? That's why I was a bit confused. No problem, no problem. All right. So, make දැන් මෙතන balance නේ. Balance in the uniform velocity මේ යනවා. Okay, how did this start moving? Okay, that's a good question. මම දැන් මේ කතා කරන instance එක වෙද්දි මෙයා already move වෙවි තිබු object එකක් කියලා අපි assume කරමු. Right? We assume that this object was already moving at 5 ms minus 1. Already move වෙච්ච කෙනෙකුට දෙපැත්තටම equal forces දෙකක් දීලා now it's balanced. It's already moving. It's already moving with 5 ms minus 1 and forces with balance now it will forever move at 5 ms minus 1. However, fortunately or unfortunately, this doesn't happen in real life. ඇයි real life එකේ හිතන්න මෙයා move වෙනවා කියලා 5 ms minus 1. හැම වෙලේම ළමයි there is a force called friction. මොකරි motion එකක් වෙනවා නම් යාට opposite පැත්තට මෙව friction කියලා force එකක් තියෙනවා. ඒක හින්දා ඕනම object එකක් move වෙලා ටිකක් වෙලා යද්දි එයා slow වෙලා නවතිනවා. Right? Friction again, I won't talk about it in this lesson because we will be talking about it in the next lesson. Make a practical in the real world, in the real life, but scientifically this makes sense. Already move with the bekakata forces with balance na ya a velocity ekema digatama yana. However, unbalanced force එකක් આવොත්, let's say I apply 10 newtons. Then මේ පැත්තට 5 Newton වැඩි නේ. So now it's an unbalanced force. Now this is unbalanced. ඒ වැඩිපුර එක්කෙනාට තමයි unbalanced force එක කියලා කියන්නේ. Now what will happen? මෙයාගේ velocity එක එක්ක වැඩි වෙනවා නැත්නම් අඩු වෙනවා. It will not move at uniform velocity. So let me tell you one more time. If an object is stationary, unbalanced force එකක් නැත්නම්, if there is no unbalanced force, that stationary object will remain stationary. But if you give an unbalanced force, that stationary object will start to move. All right. Then if you take a certain object that is moving at uniform velocity, if you don't give an unbalanced force, that object will forever move at uniform velocity. If you give an unbalanced force, ආරයාගේ velocity එක එක්ක වැඩි වෙනවා නැත්නම් අඩු වෙනවා. It will not be uniform velocity. Is that clear, ළමයි? Give me a thumbs up. All right. Then මේකට we are going to learn some examples. Okay. So එකක් තමයි let's take a carom board, right? Have you played carom before? Give me a second. Huh? Okay, I'm sorry, Lama, I got a stomach cramp, but now it's all good. Okay, all right. So, have you played carom before? Give me a thumbs up if you have played carom. Yeah. So, let's say you strike on the carom piece, right? Mama carom play karla tiyana, but I'm not very familiar with the game. However, you know, you have that මොකක්ද ඒකට ඉංග්‍රීසි වලින් කියන්නේ? ඉත්තනේ දෙකට කියන්නේ සිංහලෙන්. මොකක් හරි මේකනේ මොකද්ද? ඩිස්ක් එක. සිංහලෙන් කියන්නේ මොකද්ද කියලා මට දැන් මතක නැහැ. ඩිස්ක් එකට වා ස්ට්‍රයික් කරනවා, right? ස්ට්‍රයික් කරාම the disk will move. එතකොට will the disk move at uniform velocity? Okay, so first of all, let's see. If I don't apply a force, will the disk move? If I don't apply a force, will the disk move? No. But if I apply a force, will the disk move? If I apply a force, will the disk move? Yes. Then, when I apply a force, the disk starts to move. Will it move at uniform velocity continuously or will it stop at some point? It will stop at some point. ඒ කියන්නේ ළමයි unbalanced force එකක් තියෙනවා. Because you remember, if there was no unbalanced force, the disk is supposed to be moving at uniform velocity forever. But if there is an unbalanced force, that will not happen. So, ඒ වගේ වෙලාවට මෙන්න මෙහෙම එකක් තමයි වෙන්නේ. Let's say this is the carom board. මම ඔයාලට අර friction කතාව කිව්වේ මම චුට්ටක් එක explain කරන්නම්. Let's say this is the carom board. And this is our disk, carom disk. So you applied a force and it starts to move, right? So when it is moving, lamai, the carom board, when two surfaces are in contact, එක්කෙනෙක් move වෙනකොට අනිත් එක්කෙනා කැමති නැහැ එයා move වෙනවට. So in this particular example, when the disk is moving to my left, when the disk is moving to the left direction, the carom board doesn't like it. So එයා මොකද කරන්නේ? එයා opposite පැත්තට force එකක් දෙනවා, that is called friction. හිතන්න, you are trying to move forward. හැබැයි කෙනෙක් කෝල් පිටිපස්සෙන් අදිනවා. Can you move forward freely? ඔයාගේ speed එක වැඩි වෙයිද අඩු වෙයිද? You are trying to move forward, but someone is dragging you back or someone is pulling you back. Will your speed increase or decrease?
Increase.
Increase? Are you sure? Decrease, no? You want to move forward, you are moving forward, but someone is pulling you back. එතකොට ඔයාගේ speed එක අඩු වෙනවා. That is exactly what happens to the carom disk. The disk is moving forward. As it is moving forward, the board doesn't like the carom disk to move. Board එක මොකද
I
කරන්නේ?
didn't
Opposite.
get it.
Okay, Sala, listen. Now I'll explain again. So if you take yourself, you are moving forward at a certain velocity. But let's say somebody is pulling you back. Then your speed will decrease. In the same manner, here the carom disk is moving forward. හැබැයි carom board එක කැමති නෑ ඒකට. The carom board does not like it. So carom board, what it does is that it gives a force in the opposite direction and tries to stop the motion. That kind of a force, we call it a friction, And we will be talking about much more details about friction in the next lesson. But for now, just know that there is a force called friction. Whenever there is a motion, move වෙන එක්කෙනා නෙවෙයි අනිත් එක්කෙනා ඒ movement එක නවත්තන්න හදන්නේ. Not the object that is moving, the other object tries to stop that motion by giving it a force in the opposite direction. Here disk is moving, but the board doesn't like it. So the board is giving a force in the opposite direction, trying to stop the motion. Therefore, the speed of the disk will decrease. Then at some point, it will stop. Okay. So that is one example, one application of Newton's first law. Is this clear to you, Lamai? Others? Okay, Api, let's write all the examples one by one. I think that would be better. You wrote the law, right? Did you all write the law? I can't remember. All right, okay, all right. First of all, I will explain the law a little bit. There are a few more instances in Newton's first law. We will write it one by one. Muli metakali gonna make it fast. Let me know when you're done, Lamai. You can give me a thumbs up or let me know in the chat box. All right, Lamai. So let's talk about the next example, right? Now, you may have experience about this. Have you gone in buses? Yes. So let's say you are standing, right? You are standing in a moving bus. Let's say දෙපෙන් බස් එකක් තියෙනවා like this. So you are standing in a moving bus. Let's say you are not holding anything. You are just standing, which is a bit tricky, but let's just assume that you are standing like this. The bus is moving. Then what will happen is suddenly the driver will apply brakes. එකපාරට brake ගහනවා. Right? එකපාරට brake ගහනවා. Then what will happen? You will move forward. Have you noticed this? Sometimes even when you're sitting down, it happens. Brake ගහපු ගමන් එකපාරට මෙහෙම ඉස්සරහට යනවා නේද? Have you experienced that? Others? I mean, standing ගොඩක් අර bus එකකනේ, that's why I took the bus as an example, but sometimes even when you're seated, this happens. This is actually the reason why there are seat belts, right? So why does this happen? That is because Namai, now the bus is moving, no? In the initial stage, මුලින්ම bus එක moving. Then බලන්න bus එක moving කියලා කියන්නේ when the bus is moving, this part of the bus is also moving. The lower part of the entire bus is moving. And your feet are directly in contact with the flow of the bus. The bus is moving and your feet is directly in contact with the flow of the bus. ඒතර බස් එක යන ස්පීඩ් එකට තමයි ඔයාගේ කකුල් දෙකත් යන්නේ. You're not holding anything නේ. ඒතර කකුල් දෙකට obviously the upper part of the body is connected to the legs, no? So when the bus is moving at a certain velocity, your legs are in contact with the bus. So your legs will also move at the same velocity. Your upper body is connected to the legs. So your upper body will also move at the same velocity. ඒක තමයි මෙතන වෙන්නේ. Is that clear? Okay. Then what will happen is a driver suddenly applies brakes. එකපාරට brake ගහපු ගමන් හිතන්නකෝ can't hear? Can others hear me? All right, okay. So now the driver suddenly applies brakes, no? So let's say bus එක නවතිනවා brake ගහනවා. Now the bus stops. When the bus stops, the velocity becomes 0. Your legs are in contact with the flow of the bus. So when the bus stops, your legs will also stop. Legs වලට කිසි අවුලක් නැහැ because your legs are in contact with the bus නේ. Bus එකත් එක්ක directly contact වෙලා ඉන්නේ legs දෙක. So if the bus is moving, legs move. If the bus stops, the legs stop. So in this particular case, when the brakes are applied, the bus stops. So your legs also stop with the bus because it's connected to the bus. However, hip එකෙන් උඩ is your upper body, right? ඔයාගේ upper body එකට එකපාරට එක තේරෙන්නේ නැහැ because your upper body is not in contact with the bus. I monkey one, you're not holding anything. You're not holding any handle, you're just going freehand, right? Your upper body thinks the bus is still moving. ඔයාගේ upper body එක දන්නේ නැහැ එකපාරට bus එක නැවතුණා කියලා. The legs are in contact with the bus, so when the bus stops, the legs also stop, no problem. But upper body is not directly in contact with the bus. So upper body එක තාම දන්නේ නැහැ bus එක නැවතුණා කියලා. Upper body thinks the bus is still moving like this. So the upper body will still move forward. පස්සේ ටිකක් මේ ඉස්සරහට යනකොට දැන් lower body එක ඉස්සරහට යන්නේ නැහැ නේ because the lower body is in contact with the bus නේ. upper body එකට lower body එකෙන් ගැලවිලා යන්න බෑනේ, right? Upper body cannot detach from the lower body, right? So upper body will go forward a little and then ටක් ගාලා අපි මෙහෙම පස්සට එනවා. Because legs have stopped. So lower body has anyway stopped. So upper body එක හිතන්නේ තාම බස් එක යනවා කියලා. That's why the upper body is moving forward. ඊට පස්සේ අපි ටක් ගාලා මෙහෙම පස්සට වෙනවා. Okay, so let me explain one more time. Initially, the bus is moving. Your legs are in contact with the bus, so the legs are also moving, and your upper body is connected to the lower body, so upper body is also moving. When the bus suddenly applies brakes and comes to rest, your legs are in contact with the bus, so your legs also will stop. However, upper body is not directly in contact with the bus, so the upper body thinks the bus is still moving. So upper body will still move forward. ටිකක් මේ ඉස්සරහට ගියාම තේරෙනවා අපි හිතලම ටක් ගාලා මෙහෙම පස්සට වෙනවා. Because of course the upper body cannot detach from the lower body, right? ඒක හින්දා තමයි brake ගහපු ගමන් අපි මෙහෙම ටක් ගාලා ඉස්සරහට යනවා. See, I told you science is day to day life. Is this clear to you? Others? Okay, good.
Yes, yes.
Okay, great. Let's first write this before we talk about the other case. Man kiwi api one by one liyam, ne? That's it. That's better, I feel like. Let's write instance 2. මාත් එක්කම ලියන්න ළමයි. Quickly write ළමයි. But ළමයි, while you are writing, just listen. This is kind of interesting, no? හරියට නිකන් වාගේ body එක like there are two parts of your body. The two parts of your body are behaving in two different ways, right? ඒ කියන්නේ when the bus suddenly comes to a rest, your legs come to, your feet come to rest, or your lower body comes to rest, but your upper body is still moving. එක ගොඩක් වෙලා වෙන්නේ නැහැ ටක් ගාලා පස්සට එනවා ඒක ඇත්ත. But for a few seconds, the two parts of your body are moving in two different ways or behaving in two different ways. So this is a very interesting thing. Ekai, if you don't hold anything and just if you're standing in a moving bus without holding anything, when brakes are applied, you tend to fall forward. That's why it's important that you hold something, right? Seat එකක් හරි අර සමහර බසස් වල උඩ එලලා තියෙන හැන්ඩල් එකක් හරි මොන හරි අල්ලගෙන ඉන්න ඕනේ. Otherwise you fall forward. Okay. Others, I'll give you 1 more minute. Quickly finish writing. මේක ළමයි මේ if you are not holding anything at all, only you will like actually fall. කියන්නේ වැටෙන්නේම නැහැ ඉතින්. ඒ කියන්නේ your body obviously understand that it's now not balanced නේ. So when you fall forward, ඔයාගේ body එක ටග් ගාලා තේරෙලා ඔයා පස්සට එනවා. නැත්නම් when you fall forward, ඔයාගේ body එක තේරෙලා ටග් ගාලා කකුල් දෙක ඉස්සරහට ගන්නවා. Some sort of a way your body tries to maintain the balance. හරි. Okay, quickly write. So what happens when you hold something? So when you hold something, ඉතන seat එකක් හරි අරුඩ handle එකක් හරි මොකද අල්ලන් ඉන්නකොට your feet are in contact with the bus. Your upper body is also in contact with the bus. එතකොට no issue. Even when the driver applies brakes, you don't fall forward. චුට්ටක් එහාට මෙහාට වෙනවා, but still you don't like completely fall forward. Now let's take another instance. Now let's say you are standing without holding anything. Huh? Without holding anything, you are standing in a stationary bus. The bus is not moving. Then suddenly the bus starts to accelerate. Initially the bus was not moving, but ඊට පස්සේ එකපාරටම driver accelerate එක පාගනවා. So the bus will start to accelerate. Then have you noticed that you tend to fall back? Have you experienced this? As I said, sometimes even when you're seated, you experience this. මෙහෙම පොඩක් පස්සට යන්නේ. එකපාරට බස් එක අද්දද්දී අපි කියන්නේ සිංහලෙම කියන්නේ අද්දනවා කියලානේ, right? Accelerate කරන එක. So when the bus is accelerating, you kind of fall backwards, right? You don't like completely fall. However, if you don't hold anything, සමහරට කෙලිම වැටෙන්නත් පුළුවන්. And as I said, even when you're seated, you experience the same thing. මෙතන මොකද වෙන්නේ? The same thing. Your upper body behaves in one way, your feet or your lower body behaves in another way. In this particular case too, your lower body is in contact with the bus. So initially the bus is at rest. So your feet are at rest. Your upper body is also at rest, right? Then suddenly the bus accelerates. That means the bus starts to move. When the bus starts to move, your lower body or your feet are in contact with the bus. So your feet will also move forward. However, upper body එක තාම දන්නේ නැහැ මෙයා ඉස්සරහට යනවා කියලා. Upper body එක හිතන් ඉන්නේ it's still at rest කියලා. So the upper body is not moving forward. So එතන වෙන්නේ ඔයාව පිටිපස්සට යනවා නෙවෙයි. You feel like you're falling backwards, but actually your legs are moving forward. Your upper body still doesn't understand. Your upper body thinks that the bus is still at rest. The upper body is moving but the legs move forward because the bus is moving forward. You feel like you're falling backwards. Is that clear? All right. That's the next one we are going to write. Instance 3, no? Matakamali Anna. Quickly write this. Okay, Lama. Everybody done writing? No? Okay, all right. Quickly write. I'll give you 1 more minute. Quickly write. All right. Now, why do you think I already told you, ne? Why do you think we wear seat belts? As you think, and based on what I told you already, why do you think we wear seat belts? Yeah. Others? For our safety, because of what case? How do you explain it relevant to Newton's first law? Actually, we wear seat belts because of instance 2. Yes, correct. Because according to instance 2, the moment that whatever the vehicle you are moving applies brakes, it stops, you tend to fall forward, right? ඒක හින්දා ඒකෙන් අපිට වෙන මොකක් හරි damage එක minimize කරන්න ඒක avoid කරන්න තමයි seat belts තියෙන්නේ, right, for our safety. Okay, then ඒක we won't write it during the class, but can you write it as a question? For Q කියලා දාලා question එක ලියා ගන්න, and then you can write the answer as homework. Leave around 3-4 lines. It should have owned it නැති වෙයි. Okay, ළමයි. Make it leave about 3-4 lines and then write it as homework. Actually, Newton's second law. I'm wondering if we should start it. 9:25. No, we'll do Newton's second law next week. මොකද Newton second law චුට්ටක් කරලා if we stop halfway then I feel like අපරාධ කියලා. I would need at least like 30 minutes for this. Yeah, it's okay. We'll do it next week. ළමයි for the third lesson, I will share the worksheet. I know the second lesson worksheet was much delayed. It was overdue. However, I sent it in the group. Please check it. Please do it. I decided I will not discuss it today because I think I sent it today morning. No, I can't remember. I feel like it was today morning I sent it. Yeah, today morning tamai mama awake. So, Ekinda, I was anyways not planning on discussing it today. However, we will be discussing it next week. So, can you all do the worksheet 2 by next week? Please do worksheet 2 by next week. And also, on your textbook, page 82. On page 82, the 8th question. Page 82, 8th question. It says D, E, G, J, L, M, Q, R, and T are 9 consecutive elements in the periodic table. Anna a question එකත් homework කරන් එන්න. So you have the lesson 2 worksheet and the 8th question of the 3rd lesson, which is on page 82. Anna ඒ දෙක කරන් එන්න homework විදියට. And then I think probably not next week, but I will surely send the worksheet of the 3rd lesson as well. 3rd lesson worksheet again I have. 2nd lesson worksheet also I had already. But yeah, there was some problem. But doesn't really matter because now that I sent it, so please do it. Homework. Page 82, question 8, lesson 2. Okay, these are the homework. So I think let's wrap up. Let's wrap up the class for today. Yeah. So as I mentioned earlier, you will not be having classes next week because 14th is Urdu. And also, as I said earlier, Mama communicate kara ogalanta Miss Divyage messages sticker. And also I told you about the recording, the technical issue. Yeah. And based on what we learned today, do you have any questions? Anything that you didn't understand? Any questions? Or is everything clear?
Everything clear.
Okay. Up to which lesson are you getting, Savindu? 9th April. Wait. 9th, isn't it supposed to be a holiday? When are you getting the holidays for Urdu?
We are getting it on 10th.
10th. Oh, okay, 10th. Right. Okay. So when you're studying, if you get any question, you can let me know. Miss Divya, she will